I'm Dalton Harris, and this is my test problem 2. It's a proof. I am supposed to prove that the summation of a sub k plus 1 minus a sub k times b sub k equals a sub n times b sub n minus a sub 0 times b sub 0 minus the summation of a sub k plus 1 times b sub k plus 1 minus b sub k using associative, distributive, and commutative laws. Now, the definitions of associative, distributive, and commutative laws are as follows. Associative law allows us to break a summation into two parts. For example, if we have the summation of a sub k plus b sub k, that can be rewritten as the summation of a sub k plus the summation of b sub k. Distributive law allows us to move constants in and out of a summation. For example, if we have the summation of c times a sub k, where c is any constant, that can be rewritten as c times the summation of a sub k. Commutative law allows us to reorder the terms in any way we please. Example, a sub negative 1 plus a sub 0 plus a sub 1 can be rewritten as a sub 1 plus a sub 0 plus a sub negative 1. Alright, approaching the problem. So we have our original problem here, as you can see, and the first thing that we're going to do is we're going to use the distributive law to distribute this b sub k into the a sub k plus 1 minus a sub k. This will give us this summation right here, summation of a sub k plus 1 times b sub k minus a sub k times b sub k. The next thing we're going to do is use the associative law to split this summation into two. So we're going to have the summation of a sub k plus 1 times b sub k minus the summation of a sub k times b sub k. To make things a little easier to read and to work with and manipulate later, we're going to make this this lower bound of 0 less than or equal to k less than n. We're going to just change that to the lower bound of k equals 0 and the upper bound of n minus 1. So now what we're going to do is we're going to try to find common terms. So this is our original problem, and using the slide before, our current problem is now the summation of a sub k plus 1 times b sub k minus the summation of a sub k times b sub k equals all this on the right. So our first step is we're going to try to get this a sub n times b sub n. So what we're going to do is we're going to take out the n minus 1 because our goal is to have, like I said, the a sub n b sub n, or a sub n times b sub n in the final equation. So what this does is it makes the summation of the lower bound being the same of k equals 0. The upper bound will change into n, and what we're going to do is we're going to add a sub n b sub n. So now using that a sub k b sub k plus a sub n b sub n, we're going to plug that into the equation that we had previously. So this is our new equation. Our next goal is to get this a sub 0 b sub 0. The way we're going to do that is we're going to change this k equals 0 to k equals 1, which will mean that we need to subtract the a sub 0 b sub 0 from the left-hand side. And when we do that, we will get this equation right here, the summation of a sub k b sub k plus a sub n b sub n minus a sub 0 b sub 0. As you can see, we're, I guess you could say, 2/3 of the way done. We have 2 of the 3 terms. However, this last term will take a little bit more time. So using the previous slide, our current equation is the summation of a sub k plus 1 times b sub k minus this long thing. So our next goal is to try to combine these summations. The way we're going to do that is by reducing this k equals 1 to a k equals 0. And when we do that, we need to make this a sub k times b sub k. You need to change these k's into k plus 1s because if we were to start at k equals 0, but we really wanted to start at k equals 1, obviously you'd just add 1 to the k's. And when we do that, we also need to remember that we are starting lower, so the n needs to turn into an n minus 1. So our new equation will be summation of a sub k plus 1. Everything's the same, just the bounds are changed so that we can combine easier. So now we're going to be doing the associative law again. Just a quick reminder, the associative law allows you to break apart a summation, but also lets you combine summations. So like I said earlier, we are going to combine this summation with this summation, which will give us this equation. The summation of a sub k plus 1 times b sub k minus a sub k plus 1 times b sub k plus 1. All that's doing is basically eliminating this summation right here and cramming those together. We still have this a sub n times b sub n minus a sub 0 b sub 0. Okay, now we're going to be using the commutative law and also a little bit of factoring. Reminder that commutative law allows us to rewrite our equation in any order so long as it remains equal to the original. So basically what this means is you could rewrite -1 plus 1 as 1 minus 1 because it's the same. It's 0. So this is our current equation. What we're going to do now is we're going to be factoring out this a sub k plus 1 from this summation on the left here, which will give us a sub k plus 1 times b sub k minus b sub k plus 1. As you can see over here, we have the b sub k plus 1 minus b sub k. So what we're going to have to do, like I said, we're going to have to use the commutative law to flip these numbers. Like I said earlier, the -1 plus 1 is the same as 1 minus 1. So what we're going to do is we're going to pull that out. So we'll have a negative summation of a sub k plus 1 times b sub k plus 1 minus b sub k. Mic drop. This is where we solve the problem. So our new equation is this negative summation of a sub k plus 1 times b sub k plus 1 minus b sub k plus a sub n times b sub n minus a sub 0 times b sub 0. As you can see, it's nearly identical to what's over here. So using the commutative law, again, we're going to flip this summation and put it behind the a sub n's over here, which will give us a sub n times b sub n minus a sub 0 times b sub 0 minus the summation of all of this equals the exact same thing on the other side. So as you can see, this proof is proved.